Have you ever wondered why the most powerful AI tools, the large language models we use all the time, seem to be trapped in the cloud? Well, it turns out a team of researchers might have just discovered an absolutely groundbreaking shortcut, one that could finally shatter the AI speed limit and put all that power right on your phone or your laptop.
All right, so here's how we're going to break this down. First, we'll get into why these powerful AIs are stuck on servers in the first place. Then, we're going to get a little nerdy and pinpoint the exact technical bottleneck causing the slowdown. After that, we'll look at the aha moment that led to a whole new algorithm, see how it performs in the real world, which is pretty amazing, and finally, dream a little about the future of on-device AI this could all unlock.
Okay, first up, the AI accessibility gap. Let's really get to the bottom of why today's best AI lives on the internet and not on our actual devices. I mean, it's a fair question, right? We've all been there. Why can't we just run these incredible tools locally, without needing a Wi-Fi signal? Well, as you can probably guess, it all comes down to just raw, brute force computing power.
See, running these huge models takes a ridiculous amount of computational horsepower. We're talking about warehouses full of expensive, specialized servers. And relying on the cloud like this creates all sorts of problems for us. You get that annoying lag, it costs a fortune to operate, and you have to send your data to some company's server, which, naturally, makes you think twice about privacy.
Now, to really get the solution, we've got to focus on this one key process. It's called inference. Basically, inference is just the fancy word for when a trained AI actually uses what it knows to give you an answer. Every time you ask a chatbot a question, that's inference. And that is the exact process that we need to make faster and way more efficient.
Which brings us right to our next section. Let's look inside the AI bottleneck. We're about to find the single mathematical operation that's causing this massive computational traffic jam.
So here it is. At the heart of it all, every single time an AI thinks, it is performing just a mind-boggling number of things called vector matrix multiplications. You don't need to know the math, you just need to know this one operation is the absolute foundation of the whole process. And doing it billions and billions of times is what demands all that server power.
And hey, don't just take our word for it. The researchers themselves say it flat out, calling matrix multiplication the bottleneck operation. So their thinking was pretty simple, really. If you can figure out a way to speed up this one single operation, well then you speed up the whole dang system.
So how in the world do you attack that bottleneck? Well, that leads us to the big breakthrough, the aha moment that completely changes the game. And this is it. This is the key insight. An AI model's brain is made of these giant tables of numbers, right? They're called weight matrices. But once the model is trained, those numbers are completely locked in. They are fixed. They do not change. And whenever you have something that's static, you have a chance to get it organized ahead of time.
Think about it like this. Imagine a massive, messy library. The old way is like every single person who visits has to search every single shelf to find the one book they want. It's slow and inefficient. But this new idea is to spend some time, just once, creating a perfect detailed index for the entire library. After that, every future visitor can find their book almost instantly. That's the magic of pre-processing.
So this brings us to the algorithm itself. It's called RSR++. Let's pop the hood and see how this incredibly clever shortcut actually works. It happens in 3 steps. First, they do something called column blocking. They just chop up that giant table of numbers into smaller, more manageable chunks. Next is row permutation. Within each of those chunks, they sort all the rows so that any identical patterns get grouped together. And finally, segmentation. This is where they create a super compact little map that just says, okay, this pattern starts here and ends here. They're basically finding all the duplicate information and creating a shortcut to it.
And the immediate result of this is a massive win for storage space. Instead of having to keep that entire enormous matrix on your phone, you only need to store these tiny, super efficient little maps. I mean, it's literally the difference between storing the entire library on your phone versus just the index card catalog.
Okay, so the theory is super clever, but you gotta ask, does it actually work in the real world? Well, let's get to the numbers, because the results here are frankly staggering. First, remember that core bottleneck, the matrix multiplication? This new method sees a 29-fold reduction in the time it takes. And get this, that is not a 29% improvement. That's 29 times faster. And it's not just about speed. The model itself gets way smaller. It takes up 6 times less memory. And that is absolutely critical if you want to fit a powerful AI onto your phone or your laptop where space is precious.
But here's the number that really matters to you and me. What does this mean when you actually ask an LLM a question? It means a more than 5 times speed up in getting a response back. That's the real-world difference between a frustrating wait and an answer that feels practically instantaneous.
This chart really just says it all, doesn't it? That tall bar on the left, that's how long the standard method takes. And the one on the right, that tiny little sliver down there, that's the time it takes with RSR++. The visual difference is just incredible, and it really shows you how much of a game changer this approach is.
So let's wrap all this up by taking a step back and just thinking about the absolutely incredible impact this kind of research could have on all of our lives.
Look, this isn't just some abstract improvement for a research paper. This means AI that can respond in real time with no lag. It means using less energy. And maybe most importantly, it means way better privacy, because your data never has to leave your device. It unlocks a future where truly powerful AI apps can just run locally, making this amazing technology more accessible to everyone, everywhere.
And that brings us to one final, really exciting thought. A breakthrough like this isn't just about making the AI we have today faster. It's about enabling a whole new world of applications that we probably haven't even dreamed of yet. So the real question is, when AI isn't tethered to the cloud anymore, when it can run anywhere on any device, what will you create?